So before that, put all this laptop computers. So I was already. So welcome back to this yet another video. So in this video, I'm going to say about how to use pre-trained models like ResNet, VGG, and InceptionV3 in order to train the same classification model which we did before, that is a cipher-10 data set. So using this data set to train the retrain or pre-train or used to find 3 different models in order to check which model performs the best for our data set. So let's get into it, and before that, as usual, let us get into some theory concept. So this time theory will be a bit better because we just learned editing before. So here we go. So I hope it is visible. If not, I just try to extend. I hope this might do, but I don't know how well. And this is the maximum it's very good too. Sorry guys. And this is the architecture of 3 different models. So these 3 different models has the base of convolutional neural network, which we have seen in the previous video. And this is how we could design the architecture of a ResNet, InceptionV3 and VGG model. So as we said in the previous video, we know what is a convolution layer, what is a iteration layer, what is a pooling layer, and of course a flattened layer, dense layer. So we're just fine tuning up, just shuffling and increasing and decreasing, and just playing around with the values in order to check if the values are correct or exact, or if could just give us a good accuracy for our data set. So these weren't just a random values. These were algorithms or more which was won in competitions like ImageNet and whatnot, etc. And so these models has been used in real-time data, and they're just here with us to test with our data set. So we're eager to train it, and before getting into it, so let us see a bit comparison about here where we could see ResNet's input size, its core idea, and what are its strengths and stuff like that. And yeah, so in order to make myself clear, so what is a resonant mean? It's just skips connection. So we know that every node in the first layer will be connected at the second layer, but sometimes even some nodes will be skipped in order to avoid vanishing gradient problem. So what is a vanishing gradient problem in a sense? If we just overtrain the model in simple words, if we just overtrain the model could perform could have overfitting, so that it could just take even a noise data into consideration. Or let me make myself clear, or maybe just make myself something very theoretical that could be also understandable. So yeah, for how could I say it is like in the backpropagation process we use gradient method, or we just call it as integration and differentiation method. Some calculation, we perform some calculations over there, and if time permits, I could definitely show you how this calculation would go. But since we have lack of time, just understand it's a calculation, gradient calculation. So if the model's gradient or a level goes very a bit low, in the sense it just stopped learning or gradient becomes 0, so that the node will be wasted. So this could cause a slow learning and poor performance. So that's why skipping nodes would avoid it, and it has been done in ResNet. So inception we actually have multi-scale feature extraction. So normal scene have feature extraction, but it does the work a bit extra in order to extract features, so extract more and more features in order to classify the models accurately. So what is VGG16? It is a simple model, and the first model, I guess, which was aimed with pre-trained parameters, and it has a very simple architecture, and it's very easy to understand. So That's it from the theory part. So let us get into the coding part. So here we go. Yeah, so as we know, we just import the TensorFlow library. So TensorFlow is a library as well as a framework. So which contains an API called Keras, where Keras is just import applications like VGG, ResNet, and InceptionV3. We also get layers and models from Keras, which could be used in the model architecture and development of stuff. And we also use the dataset as Cipher10 as we used before. And this same for a change, we just use two categorical. So I just say what is it in the particular line of code, so it be a bit easy for you to understand. So using NumPy for number generation, and I hope it could be used for argmax. So what is argmax? I just explained it in the below. So we just splitting them all into x train, y train, x test, and y test. As we know, x contains the features of a particular data, which could be help us to classify or label the data, and y is the label data or actual output. We're splitting it into test and train in order to make the model learn with training data and test the model with testing data. And we are just using some pre-processing technique like dividing by 255, which could normalize the value from 0 to 255 to 0 to 1 around the okay, that is 0 to 255. This whole value is converted into just 0 to 1 in order to make the model to learn more efficiently. So we're just using two categorical of y of train into 10. So we're just using it to categorize the value where it is 1, 2, 3, etc. So yeah, y test and y y train have been converted into categorical, and just building a base model here. So what does a base model means? As we know, the base models here are ResNet, VGG, and interest. But the flatten layer, denser layer are same for all the three. So that's why just creating a function and keeping just the base model as a parameter. Then all other things have been set as a uniform or same. So we're just compiling the model and just returning the model. So this is a function. First, we're just integrating VGG16 of weight ImageNet. So as I said, the ImageNet is a competition, and VGG was one of the models which got the top accuracy, and of course the weights it's been stored in ImageNet the competition image, the name of ImageNet, so it could be imported here, and it include top in a sense the final output layer should be irrigated or minus in such a way that our input and our output would be inserted into this VGG model. So my shape will be 32, 32, 3. So 32, 32 is the size of my image, that is rows and columns, and 3 is the RGB value that we use in each and every image. So we're just building a model using the function, and it's just printing the parameters and just fitting it with X train, Y train, and we are just completely running to the entire data set 3 times and using validation data as X test and Y test in order to check the accuracy of the model. So let us see what is the verbose VERBOSC in a model. So I just typed here, but it hasn't been it is not been setting. I just check what happened. Okay, so okay, leave it. I just can come directly to the point. So verbose is a thing where the output grid, like here we can see it down, no, that like we, for example, if we just train the approach, no, it will just say approach 1, approach 2, approach 3, etc., and we get some details, but it for this particular parameter we don't want the details. So in that cases we just set verbose as 0, and we could set verbose as 1, and we can set verbose as 2. Verbose 0 in no sense, no output will be generated. Verbose 1 speed only the approach training and its progress bar will be displayed. If the verbose is 2 in a sense, it will display all the detail like accuracy, precision, like accuracy, loss, etc. will all be printed over here. So yeah, so next page is we're showing using the same concept, but this time we're using ResNet as a base model, the same weights, the same include top, the same shape. We're just importing it and we're just putting the same parameters. So next, we're just creating inception function just for a simulation. The thing is that in InceptionV3 is being deprecated in the TensorFlow current version. So we just create a simple yet create function in order to simulate how Inception V3 works. So the same thing, but we're just creating a model with our parameters instead of the real-time parameters. So we're just getting the more accuracy and loss from it by just iterating over these models and just printing it. You can see the stuffs over here, like what is the loss, what is the accuracy, etc. So just getting the result data like the same thing, but we're just getting also the parameters. And what are the trainable parameters? So trainable parameters are a thing which stands between the input layer and output layer, because that only that edges could be retrained, or we can just update to it. And total parameter, that includes the input and output, where some nodes need not to be trained. So this is a model comparison summary. So we just in this core, nothing complicated, just visualizing the model in various parameters like model accuracy, model loss, and comparing it, and we just putting a line graph using a plot method, and everything is simpler than that. It's title, X label, Y label, X text, legends, etc. And just using a for loop in order to iterate our steps. So that is a line graph and it's not been printing. So since the value is very low, the model, like the line is not being printed over here. So yeah, that's it for today, guys. I hope you all understand this code, and I hope if there's any mistake, yeah, I know it's a lot. I just try to make myself clear next time, and I will not recitate stuff. So thank you for listening patiently to my videos. Thank you. Bye.